All right, so this video is going to go through an example of how to do electron configurations with f-orbital electrons. These are tough just because of how much space they're going to take up. So just like we did with the S, the P's, and the D's, our job here is we're doing erbium down here. Remember this group right here fits in right here, so they're really in row 6 there. All right, first step, row 1, s orbital, 2 electrons. So let's go. This one I am going to write a little bit smaller. You said the S's get 1 box. There's 1, 2 electrons in there. Whoop, mistake there. 1, 2 electrons, because each arrow indicates the direction and electron spinning. Now we're down here. We're in row 2. We're starting with the s orbital. Looks like we have 2 electrons in there. Let's go 1 and 2. All right. So now I'm over here, row 2, p orbital electrons. There are 1, 2, 3, 4, 5, 6. Okay. So the p's, remember, get indented in a little bit. 2p. And before we said the p's get 3 boxes. We said we have 6 electrons in there. So let's go 1, 2, 3, double up, 4, 5, and 6. All right. So now I'm down here. 3s is going to look just like how all the other s's looked. S's get 1 box according to our key that we wrote. 2 electrons. Jump across. P orbital electrons in row 3. So indent in. 3p. 3 boxes. 6 electrons there. Double up. 4, 5, and 6. All right, so now we're in the fun row where everything gets complicated. Row 4, every row begins with an s orbital. In this case, though, we're doing 2 electrons in it. Now, these electrons right here, we colored them green. That's because those electrons correspond to d orbital electrons. We also wrote down that they don't go in the row, they go down a row, and that they get 5 boxes. So in between 4s and 3p, let's write 3d. Let's go 5 boxes. Let's go about right there. 1, 2, 3, 4. Ooh, this is going to be tight. If I count it out, I should find that I have 10 electrons right there. So let's go 1, 2, 3, 4, 5. Now I can double up. 6, 7, 8, 9, and 10. All right. So now I'm back here. P orbital electrons that are staying in their row. So I have 4p. I want to keep all my p's in line. 3 boxes. Counted out 6 electrons. 1, 2, 3, 4, 5, 6. All right. It's starting to get a little bit hard to do. Down here, 5s. Keep my s's all in a row. 1 box. 2 electrons. Almost put those going the same way. These d orbital electrons here aren't in row 5. They're in row 4. So let's go in between these two and write 4d. The d's still get 5 boxes like we wrote down. Those are bad boxes. We're going all the way through there. So let's go 1, 2, 3, 4, and 5. Now double up 6, 7, 8, 9, and 10. All right, so that gets me over here to these p electrons that are in row 5. If you notice, my d's are all kind of in a line, my p's are in a line, my s's are in a line. I'm going to try to keep that up. 5p, 3 boxes, 6 electrons. All right, down here, I'm in the row I need to be in, 6. I need to get over to erbium here. So starting off with, I have 6s. Still 1 box. I'm going all the way through these two, so those 2 electrons. All right, so now I need to do these. Let's count it out. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. These 12 electrons here, you colored these electrons yellow because they're f-orbital electrons. We said the f-orbital electrons go down 2 rows, and they're going to get 7 boxes. So they're not in row 6. They're actually down in shell 4. Now for the f orbital electrons, I'm just going to put them right next to the 4Ds. Let's go 4f. Let's give myself big long space for boxes. All right, so let's go 1, 2, 3, 4, 5, 6. All right, actually space those F's out pretty well. And I already said before, I have 12 electrons in there, so let's start by putting 1 in each box before doubling up. I need to get up to 12 electrons. 1, 2, 3, 4, 5, 6, 7. Now I double up. 8, 9, 10, 11, and 12. That is my completed electron configuration for erbium right there. I think it looks pretty cool. Really, it's just with those F's, just remember to bring them down, draw in the boxes. Frankly, I think this is way easier than doing electron dot diagrams, especially for those much bigger elements, simply because I'm not having to worry about like squeezing electrons and boxes into like the shell, the circle I've drawn. I can always go out to the right side and I can always go up. And remember, energy increases as we go up. So those F electrons actually have less energy than the 5s electrons. So they just get buried down there just to give them less energy. That goes with quantum physics, which we'll get to at the end of the year, I think, maybe. All right, if you have any questions, feel free to let me know. Otherwise, good luck with the practice problems.